So now what we're going to be looking at are calculations that involve mass and moles. So when we do this, these are instances where I give you a particular mass of a substance, say 12 grams of water, and you calculate how many moles that's going to be equivalent to. This doesn't involve any kind of calculations with representative particles or number of particles. It's going to deal with mass. So in order to do this, we're going to be introduced to this concept called molar mass. So let's take a look over here, molar mass. What molar mass is, by definition, see right here, mass of 1 mole of a substance. Now if I have 1 mole of, say, helium, that's 6.02 times 10 to the 23rd atoms of helium. That's going to have a particular mass. If I have 1 mole of, say, carbon, that's going to be 6.02 times 10 to the 23rd atoms of carbon. Now even though I have the same number of particles, the masses will actually differ, and here's why. Each individual particle for helium is different from one particle of carbon. One helium is going to have a set number of protons, 2, and electrons, 2. For carbon, it's going to be a set number of electrons and protons as well, but it's going to be more of them. So even though we have the same number of particles, each particle has a different mass. As a result, the molar mass, or the mass of 1 mole of each substance, is going to differ. So how do we calculate molar mass? What molar mass calculations involve are going to require periodic table and calculator. Okay, so let's clear all that first. Let's take a look. First example is going to be sodium hydroxide, NaOH. First thing you want to do when you calculate molar mass for a substance is make sure you get the formula. In this instance, I was generous enough to give you the formula of NaOH. Next step, make a list of all the elements that are present. We have sodium, you have oxygen, and you have hydrogen. Once we have a list of all the elements that are present, count up how many of each we have. Na, we have 1, oxygens we have 1, and hydrogens we have 1. Now we have to find out what is the molar mass of each individual element. Once we know the molar mass of the sodium, molar mass of the oxygen, molar mass of the hydrogen, we can multiply it by how many are present, and the total will give you the molar mass for this entire substance of NaOH. Well, how do you calculate molar mass or determine molar mass of each element? It's pretty simple. Look on the periodic table. On the periodic table, you'll see obviously the atomic number. You'll see the symbol, the name, and this number right here. So looking at hydrogen, it says 1.00794. That number 1.00794 is going to be the atomic mass. Now if you recall, atomic mass is the weighted average of all the isotopes of that element based on relative abundance. For us, when we deal with molar mass, all you're going to do is take this atomic mass, and rather than leave the mass as being AMUs, which is the unit for atomic mass, what we're going to do is simply change it to grams. So the molar mass for hydrogen, instead of being 1.00794 AMUs, it'll be 1.00794 grams. Rather than write out 1.00794 grams or 51.9961 grams, we're actually just going to round it to a whole number. So hydrogen becomes 1, chromium becomes 52. The exceptions to this are going to be copper and chlorine, Cu and Cl. Copper we're going to carry to 1 decimal place, so it'll be 63.5. And the same thing with chlorine, it becomes 35.5. Those are the only ones that will carry, at least for our purposes. So let's go back here. Sodium, we have 1 of them, and the molar mass of sodium, let's look back here, is 23. So 23 grams. Oxygen, same thing. We have 1 of them. Each one has a mass of, take a look, 15.9994. Round that nicely to 16. And finally for the hydrogen, I remember that as being 1 gram. So now we have the masses of each of the elements multiplied by how many of each one are present. Next thing, I have to total all of them up. So handy dandy calculator, 23 plus 16 plus 1 equals 40. Okay, so the molar mass for sodium hydroxide is 40 grams of sodium hydroxide per 1 mole of sodium hydroxide. Now right away you should probably notice that this right here is a conversion factor. Why? Because 40 grams of NaOH is equivalent to 1 mole of it. Okay, so we set this as an equivalency. We can then take 40 grams over 1 mole or 1 mole over the 40 grams. Now this 40 is unique to sodium hydroxide. Okay, it is not going to be the same molar mass for, say, phosphoric acid, H3PO4. So hopefully you guys can do a couple more exercises, practice problems with the molar masses. One thing I do want to look at is number 6. You'll see these parentheses. Okay, parentheses tell me if I have more than one polyatomic. So in this instance, the parentheses is surrounding ammonium, and this 2 after the parentheses tells me that I have 2 of them. Now normally ammonium has 1 nitrogen and 4 hydrogens. Because there are 2 of them, when I start doing the count, I'm going to actually count up 2 nitrogens and 8 hydrogens. Okay, so this is going to be a multiplier of sorts. As far as the sulfur and the oxygens go, just do it as normal because there are no parentheses. Now, how do we actually implement this in an actual calculation? Again, the same things, same rules are going to apply in terms of solving these problems. These are simplified word problems. So what you want to do is identify what you're given and what you're looking for. In this instance, it says, how many moles are in 15 grams of lithium? So let's read that. How many moles? Stopping right there tells me I want to end up at moles. Okay, so I can't start with moles because I have to end up there. How many moles are in 15 grams? There you go. That's my start. Grams of lithium. If I have grams of lithium, I can then convert that to moles of lithium. How can we do that? Well, look back here. Molar mass. Molar mass is going to correlate mass of a substance to moles of a substance. So looking back here, it says 15 grams of lithium, and we're then going to take the grams and correlate it to moles. That's my given information, 15 grams. If I have grams of lithium over here, what I'm then going to do is put grams of lithium down here to cancel it out. I'm going to put moles of lithium up top here. Now, this right here is a conversion factor. So that means that the numbers that I put in front of here and in front of here have to be equivalent. So blank moles of lithium equals blank grams of lithium. What are they? We know that 1 mole of lithium is equal to, looking at the periodic table, lithium is right here. So we find that to be 7 grams. Okay, so it's going to be, the grams cancel out, you're left with moles. And entering this in a calculator, it's going to be done. Clear all this. 15. Number here underneath, we don't have anything written. We understand it to be 1, so we can skip that. Multiply by the top number, which is 1, so we can skip that. Divide by the bottom number, which is 7. So 15 divided by 7 equals 2.14287, blah, blah, blah. This conversion factor has infinite number of significant figures, so we look back at our given. Our given has 2 sig figs, so let's take a look. The 2 is my first significant figure, this 1 is my second. This 4 keeps this 1 a 1, so I get 2.1 moles of lithium, because that's the unit that's left over. It's that simple. Okay, let's look down at the reverse process. How many moles are in 2.4 moles of sulfur? Well, in this instance, where it says 2.4 moles of sulfur, again, read the problem, find out what you're given and what you're looking for. How many grams? I want to find out how many grams there are, so that's what I need to end up with. So I can't start with that. I'm given 2.4 moles, so let's start with moles of sulfur, and then I can convert that to grams of sulfur. Why? Because, again, looking back at molar mass, it's going to give me mass and moles. It correlates between the two. So the first thing I want to do is set up my T-chart, then put my given, 2.4 moles of sulfur. Once I have moles of sulfur up here, I want to get rid of it, so I'm going to put it down here. I want to convert 2 grams of sulfur, so I'm going to put grams of sulfur up here. Now, this conversion factor, I have to set numbers in front of the numerator and the denominator so that they're equal. Blank grams of sulfur equals blank moles of sulfur. 1 mole of sulfur is equal to, let's look at the molar mass for sulfur. Sulfur is 32, is equal to 32 grams of sulfur. Therefore, entering this in the calculator, let's take a look, clear all of this. It'll be 2.4 divided by 1, skip that, times 32, and divided by 1, we can skip that, so equals 76.8. Again, let's take a look back here. We have 2 significant figures, so our answer has to have 2. My first, my second, the 8's my rounding digit, pushing the 6 up to a 7, giving me 77 grams of sulfur. So what this tells us is that if I have this many moles of sulfur, okay, it's going to have this many grams in terms of mass. Alright, now let's look at the next problem. Let's actually make this a little bit more challenging by adding prefixes. It says how many grams are in 4.5 moles. So let's switch this. Let's put a unit of millimoles. here. So that way, instead of just starting off with moles, we're starting off with millimoles. Now, look back here at the definition of molar mass. It is mass in grams correlated to 1 mole. Not millimole, not kilomoles, just 1 mole. As a result, if you read this problem, it says how many grams, we want to end up at grams, and we're given 4.5 millimoles. Therefore, my start is millimoles. But I can't convert straight to grams. Let's actually change that guy to a little m because a big M is mega. We can't convert straight to grams because if we look back here, molar mass, grams to 1 mole. So I have to convert from millimoles to just regular moles. Once we do that, then we can convert to grams. Setting this up, you're going to start off with 4.5 millimoles. You have millimoles of sodium fluoride. Well, we need the formula for sodium fluoride. So looking at the periodic table, sodium gets a 1 plus charge, F gets a 1 minus. Therefore, sodium fluoride is simply NaF. Alright, so let's put millimoles of NaF here. Once we have millimoles over here, we want to ultimately cancel that out. So let's put that diagonally. We want to convert 2 moles, so I'll put moles of NaF up here. Next thing, we need numbers here and here. If you recall prefix calculations, what you have to remember is the unit with the prefix, which in this case is the denominator here, gets the number 1. The prefix gets the 1. The non-prefix here, the numerator in this instance, gets the exponent that corresponds to that prefix. So the prefix milli corresponds to 10 to the negative third. So that becomes the exponent. Next you want to do, this right here cancels out millimoles and we're left with moles. But we want to go from moles to grams. So we have to take this unit, put it diagonally to cancel it out, and convert to grams of NaF. Again, looking at this conversion factor, we have to set the numerator equivalent to the denominator. So what number goes in front? Well, we know the 1 goes with the mole, and we need to find the molar mass of sodium fluoride. Sodium, mass of 23, plus the 19 here, 23 and 19, is equal to 42 grams of sodium fluoride. Entering this in a calculator, let's take a look how it's going to be done. Start off with 4.5. Divided by 1, we can skip that. Now take a look at this right here. It says 10 to the negative 3. In fact, even though we only write 10 to the negative 3, it's in fact going to be 1 times 10 to the negative 3. So that's how I'm going to enter it in the calculator. So it's going to be 4.5 times 1 e negative 3. Now on yours, you're probably going to have to use this plus minus function, but on this calculator here, I have to actually use this one. Kind of an odd thing. But 4.5 times 1e negative 3, which is equal to 0.001. Divided by 1 is the same thing, we'll skip that. So then next function I'm going to do is multiply by 42. That's my top number. Okay, and then divide by the bottom number, which is 1, so I can skip that. And my final answer is going to be 0.189. Now, take a look at sig figs. Our beginning number has 2. This right here is a conversion factor, so that's infinite. This right here is a conversion factor, so that's infinite. So I have to round to 2 significant figures. Looking back at this, 2 significant figures. Never start with a 0. You always start with the first non-zero. Here's my 1. My second significant figure is this 8. Therefore, this 9 pushes this 8 to a 9, giving me 0.19. So my final answer is 0.19 grams of NaF. Sodium fluoride. And that's basically it. Hopefully those 3 problems helped you out. Try the rest of the problems out on your own and we can go over it in class. Good luck.